Hello and welcome to this virtual roundtable on driving sustainable electrification, brought to you in association with Nexans, the global company that aims to electrify the future. Well, I'm Sarah Lockett and I'm going to be hosting this 1 hour session. And so let's introduce our panel. We have three top executives from Nexans, so give away when I say your name. So first up we have Ragnhild Katteland, who is Executive Vice President, Subsea and Land Systems Business Group. Hello to you and welcome. Then we have Jérôme Fournier, who is Corporate Vice President of Innovation, Services and Growth, and also welcome to you. And then finally, Vincent Dessale, Chief Operating Officer and Senior Executive Vice President of Building and Territories. So welcome to all of you. Now this session is being recorded, so it'll be posted online after we finish, and we'll be taking questions from you, the audience, at the end, but do post them whenever you think of them using the Q&A function, and we will save them up for the end after we've asked our initial questions. So what are we going to be talking about today? Well, basically the starting gun has been fired to achieve net zero carbon emissions in the UK by 2050. It's now UK law. So the British government has pledged £12 billion to make that happen. The European Commission is also aiming to be carbon neutral by 2050. Now, the UK Prime Minister has vowed to cut emissions by 68% by 2030, based on 1990 levels. But the National Audit Office here has said that will be a colossal challenge. Joe Biden has also pledged during his election campaign to decarbonize America's electricity system by 2035, so much sooner than our target. So now governments and businesses are scrambling to meet these ambitious targets. So what do they need to do, and are these targets even achievable? So the key is sustainable electrification, and that means switching transport, buildings, factories and so on over to running on electricity rather than older power sources such as petrol, gas, oil and coal. And the new electricity must be green. It must be generated from carbon-free sources such as solar, wind and water. So let's dive into the questions. Now, first of all, I'm going to ask all of you, do these new targets that have been announced, do they fill you with enthusiasm or anxiety? Do you think, finally governments have got on the green agenda and it's finally going to happen? And I'm going to come to you first, Ragnhild.
Yes, surely. And it's a very positive move, both for UK and US and also for Europe to go in this direction. As more countries take this step, the bigger chance we have to get zero carbon emission in the 30s and 2050s. And the Prime Minister announced just the upgrade of ports and factories, 160 million pounds, which should help to build back the greener. And the plan aims to create 2,000 jobs in construction with support of 60,000 more jobs. So yes, we are very enthusiastic on this one.
Excellent. And what do you think, Vincent, would you say?
Well, I think, we see it everywhere in the world. You have indeed the announcement of the UK, you have announcement of Europe. We have also announcement from Joe Biden, recently elected in US. In March next year, the Chinese government is going also to make significant announcement in terms of renewables, commitment in terms of new construction of renewables, in terms of carbon neutrality. So for sure, when you see all these trends coming from everywhere in the world, we are for sure very positive for these activities and for sure for what we are producing and delivering in terms of solutions as the Nexans.
They're certainly the right messages, aren't they, Jérôme? But, on the other hand, are they just words, or do you think they will actually happen?
Oh, that's a good point. I think that's exactly the time where it's going to happen. That's really the time that we see action. That was words, basically words in the last 10 years. And now we see at all levels, governmental level with those international policy, industries level, and at personal levels, we can see people and young generation just changing their behavior. So that's a great time that we are entering.
Although we do see, China saying the right things, but then they are at the same time building new coal power stations. Vincent.
Yeah, that's true that they are still doing this because they have indeed to to manage their own consumption, which is increasing significantly. But when you see what they are already doing in terms of renewables, in terms of offshore wind farm, which is huge, and the level that they are going to achieve in terms of offshore wind farm development in the next 5 years is above what we will do in Europe and what we will do in North America. So indeed, they are doing a significant move, and the projects are already there, they are known, so there is no doubt that they will go also in this direction.
Okay, so Vincent, if I can stay with you, how do we achieve this kind of sustainable electrification on this scale? So experts are saying that we need to build many more solar and wind farms, we need to build storage facilities, we need to digitize the grid. So which would you prioritize? Which are the easy fixes, which are the harder things to do?
Well, I think, you know, that's the mission of Nexans. This is really what is our DNA, is to electrify the future. That's also the word that we have internally. That's really our purpose. And basically, what does it mean? It means that we are delivering our solution and services in production. So you can think about offshore wind farm, about solar, in terms of transportation. So the grid in the different countries, the interconnection, and also the usage, which means also the cables inside the buildings. So we know that this electrification of the world need to be sustainable, because we know that using this green energy, in brackets, it will help to decarbonize the world. So that's really what we want to do and what we want to support as a company working in this field.
Do you put a price on how much this is going to cost? Can we even estimate the price now? Or, I mean, when we're talking globally, is it just too big a number to estimate?
The number which has been announced by the different, let's say, authorities all over the world is huge. They speak about 230 millions, 23 trillion of euros. So it's huge, huge.
Big numbers, isn't it?
Absolutely.
Jérôme, yes. What do you think, Jérôme, we have to change about electricity grids, both within countries and then internationally? So selling electricity and sending electricity between different countries to make this target happen. What do we need to change on the grids, do you think?
Well, there is, first, as we mentioned, is the electricity production. And for sure, that's the major challenge for fossil to wind and solar and distribute energy. And then there is the transport distribution from the North Sea to each town and each cities. There is two types of grid. There is new grid to build up, and there is old European grid to maintain. So we have to increase the reliability of the grid. We have to make sure that it's flexible, and we have to make sure that the electricity is still affordable. So that's the three keywords: is affordability, reliability, and sustainability of the grid.
And which of those is can you have all three at the same time?
It's always a question of compromise. It's a dream. I mean, it's always a question of compromise. But I think when you see the decrease in the price of wind and solar, and we keep going for affordable electricity, I think this challenge is going to be not that easy. But thanks to innovation, thanks to technology, we can have a better monitoring of the grid. We can have sensor. We can have a decision software that helps to make decision, and obviously some better efficiencies on cable and accessories within the grid, from the production to the houses.
And of course, when you think about that grid, we are going to come on and talk about electric vehicles in a little while. But is that going to really expand how the grid needs to operate?
Definitely. I think e-mobility is one of the key levers for the change. So there is a huge change in production with wind and solar. There is a huge change in consumption with e-mobility, e-vehicles. And so far, I think that's there is still be a challenge to balance the production and consumption. So far it's manageable, so we hope that we will carry on to have a smart grid that will be able to always balance production and consumption.
Fantastic. And you mentioned a little bit there, wind power. And Ragnhild, so we're going to see offshore wind really expanding, aren't we? And that's going to be crucial to achieving this target, would you say, that offshore wind?
Okay, clearly. Offshore wind is a very efficient and reliable energy source. And it's a natural resource. It's like what we have in Norway, we have water, hydropower. But in other places, you don't have hydropower, but you have wind. And it's reusable all the time. So wind definitely will be everywhere in the world. You'll see a great expansion of wind. The latest numbers are that it's going to be expanding by 200 gigawatts in the next period, both in Asia, in Europe, and in US. And offshore wind, as I said, it is a very steady source of power. It's out in the sea, nothing is moving, and the further out as well, even the more wind you could get. And just to think about it, if you have wind power blowing into the turbines at the 24 kilometers per hour, it will generate twice as much energy as a turbine, the same turbine with 19 kilometers per hour of wind. So it's a tremendous power in this wind.
But difficult to do offshore wind, is it? Because they have to be floating platforms, don't they? If they're far out at sea, do they?
Yeah, it's today the most of the wind farms are not floating. The most of the wind farms are fixed bottom, and they are in places where you don't have that deep waters. But forward looking in the future, yes, we will have more and more floating. I do think because you can put them everywhere. Not only where you have these banks, these shallow banks, you can put them where the wind is, which is and where you have the necessity. So yes.
Offshore is really a big, especially in the US, isn't it? It's going to be a big area of expansion, would you say, Vincent and Jérôme?
Yeah, in US, indeed, you have a significant target which has been defined, especially for the time being on the East Coast, where there is in the coming next 5 years 23 gigawatt to be built. So that's a certain number of projects which are already in the pipe and which are going to be developed. And you will have a second wave after that, more or less equivalent, which is coming in the next 5 years after this first wave. And on top of that, as mentioned by Ragnhild, you will have on the West Coast a development of floating offshore wind farm, which will come as a third wave. So you have clearly a clear roadmap of development of the offshore wind farm in US.
It's staying with you, Vincent. How did you create the sustainable, safer electrification of the world? Why does it need to be connected?
What you have to think about is that you have somehow the grid that we know, starting from the generation of energy, which is now more and more renewable, as we said before, offshore wind farms, solar farms. We have to connect this new energy to the grid, and after send this energy for the distribution to the buildings, activities of the different industry and individuals. So this, of course, will need to be digitalized in order to optimize. Because for sure, if you look, for example, to Europe, the advantage of the wind is that it's a free energy, as mentioned by Ragnhild before, but on the other hand, you don't have always wind available. So it means that in some areas of Europe, suddenly you will have a decrease of the wind energy production, which means that you will have to use energy coming from other countries in order to do this balance. And you have to imagine that this overall balance of energy consumption and distribution will have to be more and more at a regional level, not anymore at a country level. So that's the first element which will push somehow to monitor and to digitalize the network. And you have a second part, which is also very important, is that you start to have more and more, I will say, local producer. It means that you have more and more individuals having solar panels in their house, having also sometimes a windmill, just one, available. And you have to connect what we can call this microgrid, this micro production to the grid. And you will have also this small grid to manage and to integrate in the bigger grids. and to play the balance. You know, for example, that if we think about e-mobility, they think about using the car battery during the night. Because when you plug your car, you will really load the battery during the first 3 hours, but during the next the rest of the night, of course, you can use this energy to do other activities. So that's really super important to have this management, this monitoring, and the digitalization of the grid, the large one between countries, at country level, and also at a local, very local level.
And actually, I suppose, I don't know if you want to take this, Jérôme, the opposite of digitized is manual, I suppose. Is a lot of the networks, you know, operated manually or changed manually and not digitalized? Do you know what percentage is digitized and what percentage isn't?
It's difficult to say, but I believe you're right. I mean, we have been talking about smart grids and a lot of digitalization, but in reality, there is much to do. There is much to do. Now within the grid, you know, to be very simple, there is the active system, which is the substation and the transformers, and there is the cable network. And it's quite easy to put sensor or to make maintenance within the substation because everything at the right place. And if there is any issues, you can just open the door and try to solve it as fast as you can. Which is absolutely not the case for the cable network, where there is a need to have at the right place, the right data collector, sensor, and to have some experience and knowledge on how those cable network is aging, how can we use it, how much power can we increase, because that's what we are talking about, plus 2% per year, which is 20% in 2030, plus 40% of electricity in 2040. So there is definitely a need to get data and to have a data management at the same place in order to take the right decision.
Definitely, definitely. And also, just a quick reminder to people watching to get your questions in on the Q&A function if you have some particular questions that you want asked of a particular person or just to the panel generally, and we will ask them towards the end. And so staying with you, Jérôme, what are the most effective ways of dealing with new patterns of electricity demand and increasing amounts of renewable generation? If there are going to be suddenly, we're not running things on oil and petrol, we're running everything on electricity, how are you going to deal with those changing patterns?
It's as I mentioned at all levels. As we mentioned, the car e-mobility would be the most driver, but heating also will change for fossil to electrical. All the appliance industry will be electrical from production and consumption. So that's a major change within the grid.
Is that when we get into enterprise digital twins, which is kind of having a digital model of your grid, I suppose?
Based on your question, what we have to deal is with the complexity of new production and new usage. And to deal with complexity, we need a software that will be able to understand the data from the grid, production, overconsumption, over the time of the day. And that's what we call the digital twin of the grid. And if you get a digital twin of the grid, then you can make the right decision during the day if there is overconsumption, or for longer time for capex avoidance or capex opex optimization. And that's where we get into the affordability of the electricity. So it's both digital twin or asset management software can be used for the reliability of the grid. You take the right decision for a longer aging and a longer efficiency of the grid, but also for capex optimization, because we know that it's part of the challenge. It's great to have your figures, but it's gonna take some times to get this money within the grid. So it's absolutely mandatory for the DSO manager to have such a tool. And within the Nexans solution, we also include a CO2 management. That means you can calculate each decision, what is the effect on CO2 and what is the effect on capex or opex on the grid.
Perfect. So you've got a kind of a perfect view of what carbon dioxide you're making, you're creating, kind of thing. And just coming to Ragnhild for a second, because I've not spoken to you for a couple of minutes now. We were just mentioning about the offshore wind farms, weren't we? We briefly touched on those earlier. They are relatively new. They are coming, aren't they? They are expanding. But how do we need to develop them to make them more cost effective? Because you'd agree, would you, are they sort of on the expensive end of production at the moment?
The floating wind farms, yes, they are on the expensive end. And I think a comparison is for the fixed wind farms some years back. They were also at the expensive end. But through quite much work together, the supply chain and the clients, we've been able to drive the cost down of these wind farms, the fixed bottom wind farms. The same thing will happen in the floating offshore wind farm. We are finding new, more efficient, more cost-efficient solutions as we go along, and as we are building more and more of these wind farms, combining the technology that we do know from previous oil and gas industry, together with the standard and the more conventional oil, not oil, but the cable industry. And just to come back to the point of Jérôme, which is, I think, is very, very important, is the subsea cable systems that we were talking about, where we need to have digitization, monitoring, to make sure that you are able to drive the green energy from one country to the other country when that is a scarce resource. Just an example again between Norway and UK, where you have the hydro in Norway and you have the wind in UK. When you have the hydro, you're producing in Norway, you're sending that to UK where it's low wind, and vice versa. So you need this grid, that is this subsea grid that is now also being planned across the different oceans. It will be important forward to reach the climate goals.
Difficult to lay those subsea cables? Easy, expensive, cheap?
It's all relative, isn't it? It's a special workmanship. We have specialized vessels, laying vessels, and I have to say that we're happy to say that we will have a new cable laying vessel coming, of course, this next summer. Really specialized in doing these cable laying to have them safely put on the sea bottom as the most cost efficient way and quality wise. So it's all part of the package of delivering our wind farms, is also connect these cables.
And I suppose if we're talking about cables, we have to talk about the superconducting cables, don't we? The superconductor, which are, who's going to talk to me about, tell me what they are, why they're so fantastic, and why are they getting better? Who wants to take that one?
I'm sure I get this question. Thank you for the question. I think the superconductive technology and cable, that was a kind of curiosity in the 20s. And then now it's a reality that we can see really in the grid, in the US, in Germany, in UK. So the main characteristic is that a superconductive cable have no resistance. So you can imagine that you can have the power that you want to have, like the nuclear power plant power in 1 second, 1 gigawatt in 1 second within a cable. Today, it's a fantastic solution for reliability. Just imagine that in big cities like London or a big rake station like Paris, La Gare Montparnasse, if there is a blackout and if you have a 1 kilometer superconductive cable that is downtown, you can switch on and you've got 1 gigawatt in 1 second and everything light again, the trains can start again. We have seen that in UK, in France, some blackouts in part of the cities, in some railways. And the main characteristic of superconductive cable is that they are very small. It's like 20 centimeters. So if you want to have the same power on high voltage cable, what you need is overhead line, like 4 or 5 overhead line cable, which not gonna happen downtown, or you need civil works during years to just try to have a new junction downtown. So today, and I truly believe that this technology will still expand, but today it's a great solution for downtown to have reliable solution reliable network and make sure that whatever happens, you always be able to connect a substation.
So it's a good solution for sort of a densely populated kind of city area, but you wouldn't lay hundreds and hundreds of kilometers of superconducting cables. And why not?
Well, probably not now. Could happen in few years because it's still a cryogenic technology. So you need a liquid nitrogen. So it's a minus 150 to minus 200 degrees C. We are more in this range of temperature, minus 2 degrees, 200 degrees C, which is called high temperature. For you to notice that's funny that minus 2 degrees, 200 degrees C, it's a high temperature superconductive conductors, and technically we should be able to do those cables, but in terms of industry, price, risk taking, I don't think right now some of those solutions for TSO, but it's definitely a mature solution for DSO.
DSO?
The distribution, that means medium voltage downtown. You know, when you just arrive on the town with you know, a lot of people living, and then you have to distribute electricity everywhere.
Absolutely. And Vincent, you have said in the past that we need to leverage Industry 4.0, 4.0. So what does that mean? What do you mean we need to do?
New topic.
New topic.
Yeah, but in fact, it's an important one because it's also for a company like Nexans to show consistency between what we offer to our customers in terms of service and solution, and when we speak about connected digitalization, and what we do also internally. Because indeed, when we speak about Industry 4.0, it means that in our factories, we have installed sensors, captors, network, in order to monitor and optimize our production assets. So it's very similar to what we are selling also to our customers in terms of asset optimization. And we are also doing this internally. And it's not only about industry in terms of manufacturing and production, where of course you will improve your quality, you will improve your productivity, your efficiency. So that's really the added value of Industry 4.0. But it's also a little bit more. It's linked also to the supply chain part. For example, we are currently having what we call internally connected drums. So it means all the drums where we have a cable on, which are distributed by Nexans, they have a chip, and we are able to know where these drums are all over the world. And we are able consequently to collect them and to reduce significantly first the consumption, and to reduce the impact from an environmental point of view. So it's important for us to have this consistency between our position on the market, what we offer to our customer to deliver this sustainable electrification, but what we do also as a corporate, as a company, to show also that we are committed toward this carbon neutrality by having Industry 4.0 solution or digitalization of our services to impact significantly the climate change.
You were just mentioning, weren't you, about the efficiency, and I'm wondering if electricity is like water in that a lot of it is lost, leaking along the journey. Is a lot of power lost on the journey like water leaks or not?
You mean in the network or in our organization?
Yeah, well, I guess in the network generally, yes. Maybe this is, you know, kind of an idiot question, but I'm just, because we know a big percentage of water is lost, isn't it?
Yeah, it's not at all a stupid question, indeed, and that's why also when we are speaking about sustainable network, that's really what we are looking at. It means today you have indeed losses in the network because you don't have the right optimization, and what I was speaking before, this balance, which is always optimized between the offer of the energy and the demand of the energy. So having a sustainable electrification is also this, is to use modern tools, software, asset management, in order to be sure that we reduce significantly the losses. And I think Ragnhild also can jump on this one. We are also delivering technical solution, system, which are also step by step reducing the losses by a better control of the solution that we are offering on the market. So no, it was not at all a stupid question.
I'm glad to hear it. Excellent. Also,
Maybe
Jérôme,
I jump on this question because the losses are very different from one network to the other. It's moved from 2%, and it's really dependent on temperature. When the grid is high temperature, there is a Joule effect and losses. It's so 2 to 3% for a very mature and modern network to more than 40%. When the grid is not very well, the architecture, the network is not very well designed, when there is some changes, some robbery of electricities and so on. And there is a lot to do on the network efficiency. And there is a difference in between transmission, that means very high voltage line, overhead line, or ground lines, where the power of high voltage is so high that people take care of the TSO, they really are focused on the losses. When you move to DSOs and to big cities, and then it's more fuzzy. It's more complex. The use is to have as much intensity as you can of the network, and there is a large improvement to be made thanks to data management, thanks to better understanding of the grid and temperature control.
Actually, staying on that, Jérôme, are we kind of building up to a perfect storm where there are some of these aging assets, some of the grids not, the most modern, but we're suddenly going to have these demands increasing on them? Are we kind of really building ourselves up to have a big problem?
Yes, for sure. And it is part of one of the major risks. I mean, blackouts with pandemia and with cyber security is part of the three major risks worldwide. So unfortunately, we are just experimenting cyber security or cyber attack every day. We are in the middle of this pandemia, and I don't want to say that the blackout could happen, but it's really something we should take care about. And it's, I think data asset management based on data is a fantastic tool. There is smart meter everywhere now. All the utilities are having smart meters. And if we succeed to have those data at the same places and that we organize ourselves to analyze the data, then we can have fantastic improvement to manage overload and to avoid some crises and any blackouts. There is not that much changes to be made on the grid. I mean, it's not a question to make it new again, but we need to make the investment at the right place at the right time, and that's where data management is absolutely mandatory.
That's compulsory, isn't it? And actually, Ragnhild, we're thinking with Joe Biden coming in the US now, and he's got this renewed enthusiasm for green electricity, which I think it's fair to say Donald Trump didn't have so much. So what do you think should be his first actions on green electricity and on the offshore wind sector in particular? Is there anything you'd like to see particularly done in the US?
Well, at least it gives me great comfort to see and hear all the time that he has spent on talking about and messaging about the renewable energy and the importance, not only for the world, not only for US, but for the world. And as well also for US with the unemployment rate in US, he is talking about, and he wants to create 3 times the number of jobs within the sector than it is today. So he's talking about creating more than 10 million well-paid jobs within this sector. And I think the first thing that and I think he has a good plan as well, we need to have in the US release of the permits so that we can start doing the construction work for the wind farms. That's
this
kind
is
of the first
planning permission, kind of planning
permission.
Really,
actually give a go. Yes, please go ahead. All the plans are there. The pipeline is there. It's lots of developers that already are kind of banging on the doors, let us develop. And as soon as the permits are given, we can start. That's for the offshore wind. And then you need to strengthen the grid. And here's also what we've heard, what Biden has mentioned is really the need of strengthening the grid across the country and across the states to be able to utilize and to use the power from the wind farms that will be built coming forward. So yeah.
Right. Yes, no, it'd be good to see that happening, wouldn't it? And also just a quick reminder to everyone to keep getting your questions in, and we will take those at the end of the session if people watching have got particular questions to ask. So also, Vincent, you covered this a little bit about, you know, how, I suppose, factories, industrial premises need to modernize. What will the plant of the future look like? And how close is Nexans to kind of supporting this or helping this to happen?
Well, the plant in the future will look, I would say, much more with much more automation. That's really the topic. Much more automation and much more, I would say, tools to control and monitor the process, kind of a digital cockpit, if I can say this. So that's really the direction. And we have already in Nexans launched a digitalization program with a certain number of plants already involved in this program. And basically, our point of view, what we are working on currently, is to create, let's call it, leading factories, which would be really the top of the top from our point of view in terms of a plant linked to digitalization, or automation, and activities. And we do want to do this because we know that behind what is important is that behind all this, it's better quality, better cost, better safety, contribution to the environment. So behind there is a clear meaning of what we want to deliver to our customers and what we want also to be as a company, as an active player in the climate change.
It is, Jérôme, it's difficult, isn't it, to get permission to build new grid routes in the UK, would you say? So, you know, is there a way around that of kind of, I mean, you're talking about the permissions in the US, weren't you, getting planning permission to lay new grid routes? Is that something that you need to do, or do you just want to rewire or rethread the existing routes with better, more efficient cables that we were speaking about earlier, would you say?
I think both should be done. Both should be done. There is a need for new routes to have a more reliable and to increase the supply, because that's the aim. Just carry on. It's plus 20% of electricity demand by 2030. So definitely there is a need for new routes or underground high voltage, medium voltage cables. But there is also, I mean, we need to take care about rewiring and to have a recycling of the copper that is within the grid and is not used because of the insulation aging, because the cable is not on or is not used anymore. And that's where it could be also quite difficult or not that easy in some very you know, dense area on downtown.
In the centres of big cities, kind of thing. But you're laying your superconductor cables, aren't you? In Chicago, you have a contract to lay them, so you are fitting them.
Absolutely. We just finished this, or we are in a way to, due to COVID, it has been a little bit delayed, but we have this installation in Chicago with COMED. We did the same in Essen in Germany. And it's always this question of making sure that some assets in big cities are connected to different substations. One of the examples is that if you need a new high voltage cable that should cross the Thames, the river, how do you want to do that? Do you want to have some high voltage overhead line crossing the river, or do you want to have underground, but where to go? And if you use a superconductive cable, you can use a bridge because you need only 20 centimeters and make sure you have such a power that just cross the river.
Really very convenient, isn't it, for those built-up areas? And just to come to you, Ragnhild, do you think that the US kind of re-emergence in the sector of green electricity is going to have an impact on European policy making? Do you think that it will put pressure on, say, Boris Johnson to even make a tougher target and actually maybe even match the target of 2035 instead of 2050 for zero net zero emissions? Do you think that it will put pressure on European government?
I think that all these things now happening is putting more and more pressure on the different governments, and I hope to see that in the UN for this climate summit in Glasgow next year, that we will see some promises to enact change. And for UK, what I can say is that we are supporting UK and SSC Renewables Energy for the Sea Green project, where we actually are producing cables, export cables in Charleston, transporting to UK, laying it in UK, and this wind farm in itself will provide the power from more than 1 million homes. So clearly a good step forward, that one together with all the other ones to have a neutral carbon emission earlier than in 2050.
And actually, Ragnhild, you mentioned your new plant in Charleston in South Carolina in the US, which sometime late next year you're going to fully open, aren't you? $100 million newly retrofitted plant, which is manufacturing submarine cables, which is the only place in the US which does this, I think. So how much is that production facility going to kind of change the landscape? You're going to be adding so much more production into the market, aren't you?
Well, we're adding actually twice our own production from Holden. We are adding into the market. We are the, as you say, clearly stated, we are the only one now in US. And what we are working on, of course, is to provide the export cables for the US market from this plant. And with also a lower carbon footprint, because we are avoiding the transport from Europe or other places to US, it's locally being manufactured.
We've always got to count that in, haven't we? The transport costs of where you're manufacturing it in the world kind of thing. That's definitely something to think about. And Vincent, what would you say if you had to sum up Nexans' contribution to carbon neutrality in the products you offer, the way you operate? You have spoken a little bit about this, haven't you? You try and do it internally and in what you offer to your clients.
Yeah, that's absolutely true. I think we consider, and that's a strong belief in Nexans, that we need as a company to demonstrate our commitment towards the carbon neutrality. So we have made a major event in September in Paris, what we call our Climate Day, which was not really to speak about Nexans, to be crystal clear, but more to have different people from different companies giving their view on the situation of the world and how to reduce overall the emission of gas and CO2. And based on this, we have announced recently on the 18th of November, we did an ESG event where we have announced all our commitment in order to go to carbon neutrality. So it's very clear commitment. I will give you some example. We took the commitment to reduce our greenhouse gas emission by 4.2% per year. So it's very accurate because we know exactly what is our emission today. We know that we want to be carbon neutral in 2030. So we know exactly step by step what we have to deliver. In the R&D activities, we took the decision to have 100% of our R&D activities dedicated to energy efficiency and energy transition. So it's also a clear allocation of resource in this area. We are also working significantly on the optimization of our logistic flows. So it means that we want to focus our factories to their local and regional level. We will step by step stop the flows going all over the world because we consider that the CO2 impact is also part of, let's say, what we can bring to the market. And I can tell you that we have already a certain number of discussions with strategic customers to work on what we can say green offer in brackets to see how together we can bring good solution to the market. And what we want to do indeed is to use, of course, more and more renewable energy in our industrial activities. We have already some plants using solar panels. We have some plants using wind energy. And the idea, of course, is to deploy more and more this renewable energy in our site. So a clear roadmap follow on a on a monthly basis by the executive committee. So clearly a strong commitment.
I actually think that 4.2% a year on year, is quite a tough target to meet. Do you think that's achievable, or is it quite tough?
I think it's tough for sure. But you know, if you want to be part of this, you have to take strong decision. I mean, if you say to the team inside Nexans, okay, let's make 1%. Well, that's nothing else but what I call continuous improvement. So if you want to make a change, if you want to be an active player in the change, you have to get tough target. And I'm fully convinced that we can do it.
Tough talk. Excellent. Good. Now, Jérôme, we talked a little bit about smart grids earlier, didn't we? Which we're really seeing increasing to help meet the increasing demand of electricity. What are the main challenges with smart grids? Is it just installing all the infrastructure at all the different stages?
Slightly mentioned that, but there is how to make the grid smart. There is accessories. I mean, substations are already quite smart because you can monitor transformers and many of the active within the grid. When the cable network is not that smart, because most of the time it's invisible, you don't know where it is, and some DSO even have forgotten where is the architecture of the network, because it has been set up or it has been built up 100 years ago. So there is a mix in between sensor and topology within the grid, and having a data solution, meaning if the stakeholder within the grid can share the data, and we have artificial intelligence to analyze the data and to make the grid as smart as possible. As mentioned by Vincent, it could be in between countries when you need to sell or buy electricity to make smarter the consumption at the country level, but it's also at individual levels where more and more of the system should integrate an energy monitoring or energy control. So, for example, to be concrete, an electrical charger for electrical vehicle now would have a software with energy management or energy control, and then the load or the charge with your vehicle will not be the same depending of the electricity which is available on the grid. So there is smart things at every level, in your garage, at home with electrical vehicle, at the scale of the city and at the scale of the country.
And actually, as we're talking about transport, can I just kind of come to Vincent and ask you, we know that there's going to be funding for UK aviation and shipping to switch to low carbon, and electric ships are already being trialled at the moment, aren't they? How are you working to help shipping be more green?
We are, I mean, for us, we are working typically again on the infrastructure. So when we speak about ships, which are more and more electrical ships, it means that when they are at the airport, they have to connect to something in order to continue to use the network. And you have indeed in several countries, if I speak about Europe, UK is one of them. There is also a major program in Norway. They are starting to think about also some programs in France. And what we will do indeed is to bring this local infrastructure with a specific type of cables in order to have network in the harbor to welcome this new generation of ships. So it's a kind of e-mobility, not for the cars, but for the ships.
Yes, because quite often when, say, cruise ships, they come into port, they will run off their diesel engines while they're sitting in port, won't they, for all the air conditioning and all the heating to keep working. But if they can actually switch to the harbour electricity, which you're helping with the infrastructure, that's much greener, isn't it?
Absolutely, that's exactly it.
Much greener. Well, listen, we've got a couple of few questions in from our audience. So let us have a look at these. Okay. What additional risks do you need to manage in installing and operating cables when you move from fixed to floating wind? And what is the biggest knowledge gap at the moment for this step? And this is from Janet.
I'll jump on this one. So going back, for the fixed offshore wind farms, the cable are laying stable along the full route of cable route to the platforms and also to the windmills. While when we have the floating, you have a small section of the cable that is really floating, and the same is the windmills itself are floating. So the main difference in technology is how to engineer and design the floating platforms to withstand the waves and the winds at the same time. For the cables, they will only see the waves. And here we use the knowledge that we have already gained quite a lot of experience from the oil and gas industry that we have had for years, where you do have dynamic cables up to a floating vessel, for example. And we just use the same type of technology now for the cables up to a wind farm. So the technology is there. So it's more to find the most cost-efficient solution to make this the reliable source forward and cost-efficient source forward.
Fantastic. Another question. I don't know who wants to take this. When or if do you see superconducting cables becoming commonplace? And that is from Junior.
Thank you for this question. As soon as possible. Actually, what we have seen is that superconductive technology was a kind of laboratory experience. The first cable we installed was in New York, Long Island, in 23. And it was more a lab to just figure out if the technology was reliable. But since 2015, it's a real solution within a grid in operation in Germany, in UK, and in the US. So, and we have a lot of contact with some railways, utilities, to just include within the grid those part of superconductive. So within the next 5 years, I really see a change of the use of superconductive technology as a cable, but also as a fault current limiter. Because the fault current limiter, which is a nice innovation by Nexans, you can just protect the grid from very high voltage thanks to the non-linearity of superconductive characteristic.
Also for Jérôme on superconducting cables, you mentioned superconducting cables in use now on land. Are superconducting cables coming to the subsea network as well? That's from John.
Oh, thank you for this question. I don't think so, because I mentioned superconductive cable is a compromise in between power as you can and small sizes cable, which is not really the challenge for subsea. Today, the Nexans cable on subsea is mostly on the market for offshore wind farm is 320 kV, but Nexans has the right product and the qualification for 400 kV subsea or 525 kV. So we master this technology. Ragnhild can jump on this question, but I don't think there is any issue in room for subsea cable. And when we compare that to some of the specificity of cryogenic superconductive cable, I don't see this technology moving in subsea in a very near future.
What do you think, Ragnhild?
Oh, I fully agree with you, Jérôme. I think also technology-wise, the cable is a easier technology and easier to master than also the superconductivity type of cables. Just a little bit back on the floating, just to share that the first wind farm was already in production, so producing energy already back in 2017, when we finished the Hywind project outside Scotland. So the technology-wise, the floating is already there. So it's more to do more of them.
With the floating cables, do you go all the way down to the seabed and then you lay it along the seabed, or does it kind of float in the middle of the sea?
No, it's exactly what you said first. So
it goes down to the and then
goes to the seabed and then it goes. So it's only a very small section that is dynamic, that needs to be part and move along with the wave.
With the currents and that kind of thing, yeah. And just thinking about the money and the finance kind of side of it. So the UK government has said it's putting £12 billion in, and it's said that it wants 3 times that to come from the private sector, so 36 billion. So this is just in the UK. So do you see that financial burden on the private sector? Is that fair, that division of the financing, or would it be better for governments to put in more money, or what do you think? Maybe Vincent.
I think the scheme that you are giving us is I would say relatively a well-known scheme. when you speak about offshore wind farm, the past project over the last year has been already like this. It means very often you have what we call a special purpose company, which is a mix of, I would say, traditional TSO, but with some fund or sometimes with some banks, and they all together prepare and implement the project. They run it sometime for a while, and after they sell it in bracket to the public, or let's say to the authorities or the local company. So this type of scheme is already existing, and indeed that's the way which has been done over the last year to develop the offshore wind farm, and it will for sure continue. And due to the growth of the market that we have commented before, it will increase the demand, and that's why indeed you have this support from the EU, you have this massive plant in US and this massive plant in Asia, in order to give more, I would say, elements, financial elements to drive this program.
And just actually, finally, we haven't spoken much about solar, and I guess your cables, they carry solar electricity, don't they? Where does solar fit in the mix? Do you see that becoming much bigger or less important? Who wants to take that?
No, I think the solar is growing. Maybe we don't see it too much in Europe because indeed the wind is much more present. It has been developed a long time ago, but you have in Europe more and more solar for individual, that's for sure. And you start to have some very nice activities and projects of solar. And you have for sure major projects, typically more on the other side of the Mediterranean with Africa, where here you have indeed major projects ongoing. You have also some ideas to have floating solar farm. This is also something which will come in the future. And we have indeed specific solution for that. Maybe Jérôme, you can comment. We have a specific company that we have for which we have specific solution for solar, maybe?
Yeah, for sure. We are very committed to advancing in solar technology. We do have a long track record on providing cable for solar. Now we provide the harnesses. We try to make the installation as fast and reliable as possible. So we propose those products, which is Kelios harnesses for solar. And we have a company which is a solar tracker that's allowed to have a very robust tracker that could resist to any kind of bad weather to increase the yield. I mean, the yield in solar has increased from a tremendous point of view. I think it's very close. Some results this week were very close to the theoretical yield in terms of solar panel. And thanks to double solar panel and thanks to tracker, people are extremely smart and innovative in increasing the yield of solar. So now is the cheapest way to produce electricity, and that's will carry on for sure.
The cheapest way it is, isn't it? It's cheaper than new gas or coal-fired power stations. With wind power is the next cheapest. So this is the way to go, isn't it? Once they become cheaper, then that's when people will really go for them, isn't it? Listen, all three of you, thank you so much for taking part in this session today. I think it's been really interesting and we've got a lot of interesting topics covered. So thank you for that. And do remember that the recording is going to be distributed to all attendees when we have got it really quickly edited together in the next couple of hours, kind of thing. Don't forget also that Nexans will be holding an Investors Day on February the 17th next year, which is a capital markets day to hear more about the company's strategy and culture and values and things that are coming up in the next few months. So thank you again to our guests. Thank you so much for taking part. Thank you also to our director producer Sean Evans at Top Line Film, and also to our question moderator who was Katie Schuff, or also at Top Line Communications. So thank you, our audience, for joining us as well. And for now, it is goodbye from us. Thanks a lot.